Thank you, Amrish. Morning. Last night was heavy. It's a bit of injury. So I wasn't previously scheduled to give this talk, but unfortunately, one of the previous speakers who was supposed to be here didn't make it, which is fine. I mean, 100 gig in and of itself is not that interesting. I suppose what's interesting about the talk is the experiences we went through to get it up and running, and which is what I'm going to share here. So map of CCOM, you know what CCOM looks like. That's the cable. We're on the east, and then we have a network on the west, et cetera, et cetera. So the reasons for the upgrade for us was primarily driven by the fact that South Africa is the biggest growing market for us, and it's also a transit point between CCOM and WACS. What that means is, you know, if we need to move traffic from, say, East Africa, say Tanzania or Kenya and so forth, down to WACS, that's going to transit through Johannesburg, through Cape Town, into the core network. And there are reasons why that would be the case that I'll discuss just now. This has been our typical standard deployment for the core, which was a Cisco CRS 8-slot chassis. This is the CRS B chassis, which can support up to 400 gig per slot, with a Cisco 6880 switch running as a core switch. And I'll explain to you why we did that. So the reasons we do this kind of design, because typically in some larger networks, you find that the core router aggregates all other devices within the POP, the route reflectors, edge routers, peering boxes, etc. In the larger POPs for us, we use a core switch, core router design, because then it allows us to aggregate devices individually onto the core switch, which are cheaper ports than aggregating them into a CRS, for example. If you do that, you strand capacity. Connecting a route reflector that will probably only have maybe 2 or 3 meg of bandwidth at any point in time into a core router is going to cost you a gig port or a 10 gig port. It's also easy to add devices into the network because you're connecting them into a core switch as opposed to a core router. So you're not touching the core router at any point in time. And then traffic that's normally hitting the core router only needs to leave the POP. So you don't have a core router circling internal traffic within the data center. So you free up a lot of capacity by doing that. And also because you're not involving the core router in a lot of the interconnectivity within the POP, you can do maintenance, upgrades, and so forth that's independent of the core router itself. So what we've typically done, in Joburg and Cape Town, previously we had this, which is what we still have in our other largest facilities like, Tanzania, Mombasa, Nairobi, London, so forth, is a 14-port 10 gig line card and a 16-port 10 gig line card on the switch side. The switch side is actually oversubscribed twice, so it's actually only 80 gig in terms of throughput. But that's fine because we only put eight links in one of those cards at any point in time. So like I said, 80% of the POPs have that setup, and that's great because within the data center itself, there's not that much traffic that's running around to necessitate either 40 gig or 100 gig. But in the case of Joburg and Cape Town, we had situations where you're delivering large capacity EOMPLS flows that you can't easily load balance because, well, it's Ethernet. And trying to load balance that across multiple 10 gigs is just simply almost impossible. And then also, when you lose, say, the CCOM cable has an outage, customers from East Africa need to reroute across WACS. So all that traffic needs to come down across the southern portion of the cable system into Zini, into Johannesburg, down to Cape Town, and then across to WACS. So there's a lot of intra-data center capacity that needs to be handled between the core routers at that point in time. And then also, well, South Africa is just growing quite massively. So the new setup right now for Joburg and Cape Town is 4-port 100 gig line card on the router with an Arista 7508E switch. And the Arista has got two line cards. There's got a 12-port 100 gig line card, as well as a 48-port 1x10 for the legacy infrastructure. Yeah. So why Arista? Well, price-wise, per 100 gig, it was the least expensive. If we considered Juniper and Cisco, Arista came out much cheaper. So it made a lot of sense to go that way. And also from a feature perspective, we don't run a lot of features in the core, just purely moving Ethernet frames. They did everything we needed. That was really it. Why do we keep the CRS? Well, we've had it for a long time. I think when we bought the CRS back in 2014, I think Juniper had, not mistaken, I think the T4000, the PTX, I think had just started rolling out. And also, we also needed to maintain some legacy support for SDH infrastructure in some of the POPs, but these days it's not such a big issue anymore. Mostly wherever we go, you can get Ethernet, but in some dodgy places, you can only get SDH. And you know, most of the cheaper routers today are mostly Ethernet, so that's why we keep the CRS. The Nokia option, or ALU at the time, would have meant a third vendor, and you know, maintaining two is hard enough as it is. So we tried to stay away from the third one. Yes, Arista is a third vendor, but to be fair, the use case right now is not that complicated. We're not touching the box too much for it to be a major issue. Main issues with the CRS is that 4-port 100 gig line card is massively expensive. But you know, for us, again, it's the deployment is only in these two locations right now, so it was a decent trade-off. The CPAC optics are also expensive, but you know, that's 400 gig, you know, capacity. You figure you don't want to muck around with that too much. In terms of expansion, well, Cisco say the box will ultimately do 800 gig per slot. That was a promise they made back in 14, 15. Obviously now, you know, times change. They're pushing the NCS, so who knows what will actually happen. But we don't need that kind of capacity in the majority of our POPs, because that's, you know, that's 400 to 800 gig per slot. You're looking at 8 slots between 2 chassis. It's a lot of capacity. So we're not in any hurry to go to the NCS platform. Couple of challenges. So initially we had, before we decided to move on with the Arista, we actually began to order the Nexus switch. And then I think it was such perfect timing that we managed to land on the Arista team in South Africa. And they came at the right moment when we were just about to start shipping. And their offer made a lot of sense. Unfortunately, we had already started to ship the SR4 optics as well. You know, for the Cisco and SR10 for the Arista. So what happened was when they all arrived, you know, you have a 10-lane optic and a 4-lane optic. Obviously, that won't work. So we lost about a month trying to fix that. 100 gig experience, we realized in Africa is not that great. Getting local support for optics, cables, MPO cabling, the local resellers, it was just a nightmare. We eventually, I think, shipped in some MPO cables from Flex Optics. I think some of them also came with some issues, so we had to reship some more in. Ultimately, we couldn't get those cables locally in South Africa or anywhere in Africa. And when we rang up some resellers that do these kinds of things in Africa, they're like, what's an MPO cable? So it was, we lost about easily 2 to 4 months just around that. In terms of logistics, try getting a 400 gig line card through customs. they didn't have a line item for that in their audit system. So that was also a little bit of a drama. On our side, in terms of the physical deployment of the infrastructure, the CRS3 is 140 gig fabric, so per slot. Moving to this, now you had to move to a CRS10 fabric, which is 400 gigs per slot. So which we knew before we began the actual deployment. Unfortunately, there were some resource changes within the business. Some people left, others joined. So that part was forgotten. So you slot in a 400 gig line card and it doesn't come up. You lose about a week figuring that out until you realize, oh, they forgot to upgrade the fabric as well. So things like that do happen. On the Arista, really, Arista were taken to court by Cisco because the codes look so similar. For us, it's much easier because it does look like iOS. So not a lot of training that was required, to be honest. And for us, a major factor in the decision process to go with Arista, really, there's almost no difference, cosmetically. Obviously, under the hood, EOS is a lot more advanced, but cosmetically, it's almost the same. Vendor lock-in, yeah, the optics. So this is the one part where I think Arista really bent over and supported our requirement to not lock the optics in, because we had a lot of optics we'd purchased for the 1 gig and 10 gig infrastructure that had to move across to the Arista ports. And we made it a requirement that if we're going to go Arista, that has to be supported. While it's almost kind of like you're on your own, they say, well, here's a code, unlock the ports and you'll be fine. And we're okay with that. So it saved us, almost another 95% worth of costs of optics to move across to Arista. In terms of data centers, the Arista requires 16 amp power, but that's fine. We just had to make that alteration with the Terraco facility and also needed more rack space because we now went from, I think the 6880 is a 4U, and I think the 7508 is half rack, I think, 21U, yeah, 13U, there you go. So that's what it looks like. It's real. So that is a 7508E switch there with, as you can see, two pointer. Light. So yeah, all AC, don't believe in DC. So 4 AC power slots like that. That's the 48 port 1x10, and this is the 12 port USFP 28 100 gig line card. And then on the Cisco side, it's a bit dark, but that's this is the 2 line cards here of 4x100 each, talking to the Arista. And that's replicated for Cape Town as well. That's it. Thank you very much. Any questions? Has to be Nishal.
No. Oh.
No, Nishal, come. My mic is on.
Okay, Nishal Govardhan, curious person. So, sorry, I missed the first part. What level of 100 gig support were you looking for? What density were you looking for? I mean, it's easy to say that I want to get something that's going to do, I'm guessing it's easy to say I'm going to get something that's going to do, I don't know, 64 100 gig ports in 1 rack unit depth. So what was your criteria? Were you looking to support 100 gig port, 64 100 gig ports per pop, 200 100 gig ports per pop?
We only needed 10.
10. So isn't I mean, sorry, I'm not as much a hardware geek as I used to be, but wouldn't 13 rack units for a switch seem quite high for 13 or 10, 100 gig ports. You can do those in smaller form factors these days, right?
Yeah, so you're right. So we went for a full chassis system because this is the core. So we need the redundancy on the fabrics, on the control plane, et cetera, et cetera. The half of that from Arista is a couple thousand US difference in pricing just for the chassis itself. More of the cost is in the line card, and the line card is the same. So for us, the future expandability of having more slots in the chassis made sense than going for a smaller chassis where you're not actually making a real saving on the hardware itself. You know what I mean?
No, I don't.
Okay.
So sorry, let me try to ask this a different way. I mean, is your architecture such that you just have a centralized core device and not two core devices? Because if you had two core devices, then having a pizza box 100 gig switch, if all it's doing is layer 2 switching, makes it super easy, cheap, small, lightweight in terms of power.
Agree, but this is a core facility, and yes, two pizza boxes seems like it makes a lot of sense, which is fine. But the amount of capacity we're talking about running through the POP, I'd rather not risk it. And you know, I'd prefer that we have the independent redundancy from a hardware perspective on each of the chassis, even if it's only doing just Ethernet, which is what we do also for the core routers and the edge routers and so forth, even if they are still redundant. But then also, because the cost of the chassis itself is not that significant, we figured let's get more slot capacity in it for whatever comes up in the future. The same decision we made not to ever buy an MX240, because you know you only get two slots and you can't do anything else. The cost of the chassis itself is nothing. It's the line cards where the money's at.
Right, absolutely. Yeah. So to me, I'm sucking here, a 32 port 1U 100 gig switch, which I know is available from various vendors, would seem cheaper and cheaper to support in the long run than a chassis, which needs expensive line cards.
Yeah, but then remember also, we had to support the legacy, the slower ports, the 1 gig and 10 gig. Okay. So the reason a dedicated 100 gig only pizza box wouldn't work, I suppose you could go for QSFP28 ports that you can then downgrade into 10 and 1, but then that's starts to make things rather complicated. So, you know, supporting the slower ports as well was a requirement, hence individual slots for different rates made sense.
Hi, Donald Jolly, person as well. My question was actually going to be quite similar to Nishal's in that why did you choose to go for a chassis rather than creating a cross fabric with a couple of 1U boxes? But I noticed that with this, you didn't look at the junipers at all. You didn't look at the junipers for any of the your switches. So your core switch upgrade.
We did. So I think the QFX as well as the EX9000, I suppose, is just overpriced, massively overpriced.
Yeah, and so on the cost there, I mean, are you looking, and not necessarily in your core, but generally in your network, on white box networking and disaggregating the software from the hardware? Are you looking at that generally or not?
I'll be honest, at this scale, it's too risky for us. We're happy to lab it and maybe do some corner case deployments, but at the kind of scale, it's a bit too bleeding edge.
Thank you.
Yeah.
That's a fantastic statement. And that's one of the questions I had. It's Nishal again. Because a couple of years ago, you did a really cool presentation about how you moved your routing control plane off traditional routers onto PC, well, server-based hardware.
Right.
So it's fantastic to hear you say that this is too bleeding edge, because you've effectively moved what is the decision-making ability of your network onto servers.
Well, that's also bleeding edge, but it's controllable because the amount of traffic flow the device is dealing with is nothing, right? trying to run, several tens or hundreds of gigs of network traffic through a white box is a whole other thing. That's the main reason. So the route reflector side is easy to do because there's no real traffic.
Conservatively liberal or liberally conservative.
A bit of both.
I appreciate that. I was also curious about the vendors. You didn't mention Extreme or Brocade, whatever they call these days. I'm curious, is it because you didn't find a reseller in Africa that could support you?
So to be honest, we did get in touch with Brocade, but the account management team in South Africa just aren't there. I think we spoke to them, I think, for some FTTH stuff, for example, 2 years ago. They completely disappeared. Got in touch with them for this as well. No response. You have to move on.
Fair enough.
Yeah.
And then I was curious about the lock-in that you were speaking about, of optics lock-in. Now, that's obviously an old thing.
Nice, right there. Feel free.
Well, no, this is more general than Werner, but that's obviously a thing that existed for a long time in the industry. And then there's this wonderful orange company, or orange branded company, that has come up and liberated those of us that have been stuck in this world. I won't mention any names. We're not allowed to mention names. You can look around and figure out who I'm talking about. We're a big fan of that orange branded company because they've done that for us.
Yes.
I run an exchange point, and we have 3 different vendors that we've had to migrate through over a period of time. And they've allowed me the opportunity to move my optics around at will. And that's fantastic for me. But I'm curious if you're still encountering these things. Because when we bought our last set of hardware, we went specifically to the manufacturer and said, I'm not interested in your lock-in procedures. If you even mention the words, buy my optics, we are walking out the door right now. And we didn't encounter that. Oddly enough, Arista did mention that to us, and they said, we'll give you the code without us even asking, as if it was a deal sweetener kind of thing. And for me, that was a non-negotiable item. I don't buy hardware for big networks like you do. You still get those from the vendors?
No. To be honest, Juniper and Cisco don't really care. They have the standard. If you open a case that has a non-Cisco, non-Juniper optic, then but no, not really. Arista were actually the only ones that had sort of suggested that, if you don't take the optics, then, and we're like, well. So yeah, we found some middle ground. So moving forward, buying more Arista infrastructure, that's not a problem. And yeah, you're right. The work that Flex and Flex have done for the area is quite, we like them. We like.
And then in terms of learning iOS, you mentioned that Arista was actually really, really easy to use. There's this other company that comes from East, which has a remarkably similar. Did you not consider them as well? Were they, asked a different way, were there security concerns about using the equipment? Or was it just we're not interested in their products?
Yeah, we're not interested in Huawei.
Okay. I didn't mention the name. Yeah. Thank you.
Thank you. All right. Thank you very much.